Hello everyone. In this video we're going to see some ways to calculate the moment. So recall a moment is a vector generated by a force with respect to some point O. So let's say we have a force, I have a point O, then there is a moment acting about O that's defined as r cross f, and r being the position vector that goes from O to the tip, or to the tail of f, and we generate a vector which I'm going to denote with this curved arrow. So this acts about, or acts with respect to, point O. Okay, and this axis about point O, axis perpendicular to R and V. Okay, and we saw previously that we can evaluate this by taking the magnitudes of the vectors, take the sine quantity. So this theta is the angle from R to F, tails together. So in this case, I'm going to draw the tails together, move this vector. This is theta. And U is a unit vector. So that indicates the direction of where the moment's going. Remember, M is a vector. It has to have a direction. And this unit vector is perpendicular to R and F. So R and F are going to define a plane. The unit vector is perpendicular to it. And in the direction, following the right-hand rule. So the right-hand rule, we take our right hand, we point it in the direction of R, fingers go in the direction of R, curl to F, and our thumb is going to point in the direction of the moment vector. So in this case, my fingers are going to curl around in the same, following the curled line that I've drawn here. My thumb points into the direction which is going to be into the page. So in this case, U is a unit vector which is perpendicular to this page. It is positive or going into the page. Okay, so if we want to calculate this, one way to do this is start with a reference frame. And I'm going to start with X, Y, Z coming out of the page, and then I'll have vectors, unit vectors I, J, and K in each of these directions. With this reference frame, I can write the position vector in general having components in all three directions. Likewise, I can write the force as having components in all three directions in general. So we'll have an I component, a J component, and a K component. All right, so let's evaluate this cross product, and this follows from the definition of the cross product. Let's write these out, and we'll see a few terms. We won't write out all of the terms, but let's look and see how things go. Okay, so we're going to take the first term, we're going to evaluate the first term. Collect these magnitudes, I cross I. The second term is going to be this one cross this one. So that's RxFy, I cross J. And then this term here, and then I'll have I cross K. And then I'll repeat this process with these two terms, leaving me with 6 more terms. So 3 from this one crossing each of these, and then taking this one crossing each of these, 6 more terms. All right, so let's evaluate some of these. So I'm going to take the cross product. I'm going to look at the definition here. So the angle, I to I, 0, right? Sine of 0 equals 0. here we have angle between I to j. That's 90 degrees. So sine of 90 degrees is equal to 1. Likewise, the angle between I and k, 90 degrees. Sine of 90 degrees is 1. So we have the magnitudes here, and let's find the directions. So we have 0 here, I cross j, so that if we follow the right-hand rule, so let's draw this here, I, j, k coming out of the page, right? So if I put my fingers pointing in the I direction, curl them to j, I'm going to get a k coming out. So I cross j is k, I cross k, we do the same process. I put my fingers in the I direction, let's see, I direction, curl them to j, and then my thumb is going to be pointing in the minus j direction. So recall we have a way to remember how this rotation goes. We could draw this in a circle, right? So we're going to be positive clockwise, negative counterclockwise. So I cross j is going to be a positive k, and I cross k, we're going backwards, is going to give you a minus j. So this is going to be a negative j, this is going to be a positive k. Okay? All right, so if we do this with all the terms that we have written out, then we will end up with, so equals, so the first term, 0 plus rx fy, we decided that was k, and then rx, let's see, fz, and that was minus j, and then we have our 6 other terms here. Okay, so if we follow the procedure with the 6 other terms and collect everything, then we're going to end up with a component in the x direction, so multiplied by I, a component in the y direction, j, and a component in the z direction, k. So these are the components of the moment. The moment is a vector in the x, y, and z direction. Okay. Now I'll show you a way to calculate the magnitudes, which you can use to calculate the components of the moments. That may be easier to use depending on your geometry. Okay, so let's start out again. Let me write this out so I can refer to it and evaluate it again. Magnitudes. Right, so this is the magnitude and the direction indicated by the unit vector. All right, so if I take a vector, the force vector, and I have my point again, so here's r. So, right, so this is generator of the moment MO, which is actually about point O. All right, so now I'm going to draw this. I'm going to form the triangle. So the first thing I'm going to do is take a line that's collinear to F. And I'm going to draw the perpendicular line here. And I'm going to say the length of this segment is D. So D, length of segment, perpendicular to line collinear with F. All right, so if we look at geometry here, where's our angle theta, right? So we put the tails together, R and F. So this is theta. Okay, so by geometry we can see this is theta. So we can see that sine of theta equals D over the magnitude of R. So that D is equal to R sine theta. So if we're taking this quantity, we're going to take this and this together. So we'll take these together, leaving us with this term in the unit vector. So this, D, is the magnitude, scalar magnitude. Well, I guess this, so together, so scalar magnitude. So in some cases, depending on your problem, you may have some kind of body here, and you're applying a force to the body. The body is going to rotate about 0.0 due to this moment. In terms of calculating the moment, you can find this r vector, but by geometry, it may be easier just to look at your problem, determine this perpendicular distance, and then calculate the magnitude of the moment from that.